Welcome back to the deep dive. Today, we are wading into probably the most polarizing macronutrient out there, carbohydrates.
Absolutely. They get demonized all the time in diet trends, don't they?
They really do.
Yeah.
But fundamentally, carbs are the body's main fuel source, its preferred one. They're literally the driver for your energy.
Yeah, if you're training hard or even just, trying to get through a long afternoon without zoning out, you need them.
Exactly. So knowing how to use them properly is crucial. We've gathered a pretty comprehensive stack of your sources today to try and cut through some of that confusion. Our mission really is to clarify what carbs actually do, maybe demystify the whole simple versus complex thing, navigate the real risks around sugar timing, which trips people up,
Definitely.
and importantly, nail down the specific fueling needs for serious athletes.
Okay, so let's kick off at the basics because honestly, it's non-negotiable. Carbohydrates are absolutely essential for creating ATP adenosine triphosphate.
Right, the energy currency.
That's it. It's what your muscles, your brain, everything runs on. Chemically, they're simple, just carbon, hydrogen, oxygen, and each gram gives you 4 calories. Pretty consistent. Now, the sources often mention this general guideline like 55 to 60% of your daily calories from carbs.
Yeah, you hear that a lot.
But the reality is that number varies massively depending on your activity level. You can't really talk about performance without going beyond just that baseline percentage.
Okay, good point. So let's unpack this classification then. Simple versus complex. We hear it all the time. But what's the functional difference, not just the chemical chains?
Functionally, it really comes down to structure and speed of digestion. Simple carbs are your basic sugars, glucose, fructose, sucrose. They need very little breakdown.
Like kindling for a fire.
Exactly. Ready to go almost instantly. Complex carbs, on the other hand, are long chains of these sugar molecules strung together. They're more like dense logs. And what's really interesting, and maybe surprising to some, is that no matter the source, could be a sweet potato, could be a candy bar, all carbs eventually get broken down into single sugar units.
Right, it all becomes glucose or fructose in the end.
Pretty much. The critical difference for performance is how fast your body gets access to that sugar and that speed. It's affected by everything else you eat with it. Fat, protein, fiber.
Ah, fiber. Let's talk about that. We often forget fiber is technically a carb, don't we?
We do, and it is. It's a complex carb, but the trick is your body doesn't really have the enzymes to break it down for energy. So it mainly acts as, well, roughage. It doesn't give you calories, but its presence is super important because it slows down the digestion of all the other sugars you're eating.
Okay, so complex carbs digest slower, which is why they're often called healthier sustained energy, less of a sugar rush.
Right. Avoids those big blood sugar swings.
But, and this is the key bit for athletes, that slower digestion might actually be a drawback sometimes. What's that performance trade-off?
The trade-off is immediacy. Simple as that. If you need fuel right now, think mid-race. Or during a really heavy lifting session, that slow, steady trickle from complex carbs might not be enough. Your muscles are demanding fuel fast, and the complex carbs might not deliver it quickly enough.
So high-performance fueling isn't about choosing one over the other. It's about balancing that steady foundation with, like, tactical fast fuel.
Precisely. You need the logs for the long burn, but sometimes you need the kindling right away.
That brings us right into the big controversy, the sugar spike and the dreaded crash. We hear so many warnings about sugar and insulin. If someone's generally eating well, what's the actual danger here, especially thinking about performance? Is it overblown?
Well, the long-term risks like diabetes or chronic energy issues, those come from, consistent, excessive consumption that the body just can't handle over time. But for an active person, someone listening to this, the real risk is usually acute. It's what we call the timing trap during exercise.
Okay, the timing trap. Tell us more about that. What happens if you, say, down a big sugary drink right before you go hard?
Okay, so the problem is the insulin response. You load up on a ton of simple sugar, maybe a big energy drink, or a couple of candy bars right before you start working out. Your body releases a wave of insulin to clear that sugar from your blood. That's its job.
Makes sense.
But then you start exercising, and your muscles are also pulling sugar out of the blood like crazy for fuel, so you've got insulin working overtime, and your muscles draining the tank simultaneously. The result?
Yeah.
Your blood sugar plummets.
Ah, so that's hypoglycemia.
Exactly. And it's not just feeling a bit tired. It can be a really debilitating energy crash right in the middle of your session or hitting you like a brick wall right after. Your main fuel source just vanishes.
That's a much clearer picture. It's not just vague sugar is bad. It's a specific physiological mechanism the body's response backfiring due to timing.
That's it. It's too much, too fast, at exactly the wrong moment. The sources are pretty clear. If your overall daily fueling is balanced and you avoid those huge immediate sugar hits right before training, you're generally fine.
It's the tactical misuse, the timing, that we need to avoid.
Precisely.
Okay, so since timing is so critical, how do the rules shift when we move from just general health to really specific, intense training needs? And athletes' needs are a different ballgame. Your sources gave us a good framework for assessment here. For you listening, to tailor your strategy, you need to ask yourself 3 key things. First, is your sport mostly aerobic, like long run, cycling, or anaerobic, meaning short, intense bursts like sprinting or lifting?
That's question 1.
Second, is your current training block heavily focused on aerobic zone work? Are you building endurance, spending lots of time in that zone? And third, and maybe obviously, do you have body composition goals? Trying to lose fat, gain muscle, or just maintain?
Those 3 questions really frame everything. For example, athletes doing tons of aerobic work, marathoners, triathletes, maybe soccer players covering lots of ground. They're operating mostly in that, say, 60 to 75% max heart rate zone.
Right.
They just burn through glycogen. Their carb needs are significantly higher. Contrast that with maybe a powerlifter or a 100-meter sprinter. They definitely need carbs for that explosive power, but the total duration and volume are usually much lower.
So their overall daily need might not be quite as astronomical outside of specific pre-lift fueling.
Generally, yes. The need is really dictated by the time and the intensity of the actual training sessions themselves. Longer and harder equals more carbs needed.
Which leads us right into the keto and low-carb discussion. This is probably the fiercest debate in sports nutrition right now. And the source material we looked at offers a perspective that, well, it's controversial, so we need to report it neutrally here.
Indeed. And look, if you're fully bought into the keto lifestyle for performance, this might be a tough pill to swallow. But the source material basically says a functional athlete's fundamental need for carbs isn't actually that different from anyone else's. It's driven by the energy you expend during training.
Okay, but hang on. Lots of athletes do report feeling great and performing well on strict low-carb or keto diets. If the body needs carbs for high intensity, how do the sources explain those perceived benefits?
Right, good question. The sources suggest a couple of things are likely happening there. First, often athletes going low carb achieve a calorie deficit simply by cutting out a major food group. They lose weight.
And less weight often means faster times or feeling more efficient, regardless of the fuel source.
Exactly. It's a body composition benefit, not necessarily an energy system one. Second, and this is quite insightful if you're usually running on very low sugar levels, and then you strategically introduce even a small amount of carbs.
Like right before a race?
Yeah. The absorption can be incredibly efficient because there's less sugar already circulating. That small dose can feel disproportionately powerful, giving a real kick.
Ah, so it feels like a superfuel because the system is primed to grab it instantly.
Potentially, yes. It's maybe an optimized use of a small amount, rather than proof that you don't need more carbs for optimal performance overall.
That's a really important distinction. Okay, let's get tactical then. Let's say you've done the assessment. You know you need high carbs for your training volume. How do you actually get those amounts in and when?
Right, this is where we move into the high performance guide, and it's all about timing. It's crucial because getting carbs in correctly restores glycogen, keeps blood sugar stable, and really boosts endurance. So, before you train, a big load happens 3 to 4 hours out. The goal here is to completely top off your muscle glycogen stores. The recommendation: 200 to 300 grams of carbs.
Whoa, hang on. 200 to 300 grams. That sounds like a lot of food. How are people supposed to manage that volume a few hours before training?
It is a lot. You're talking what, like 4 big bowls of oatmeal, maybe 5 large sweet potatoes? It's significant. The sources stress using complex but easily digestible sources and giving yourself enough time, but yeah, it's bulky.
So what if you train first thing in the morning? You can't eat that much at 4 a.m.
Good point. For early training, the sources suggest a fluid alternative is viable. About 90 minutes to 2 hours before, you could use a carb drink, ideally one with some electrolytes, some salts. And then, for a more immediate tactical boost, about 1 hour before, the research suggests 60 to 80 grams of simple sugars dissolved in 1 liter of water can really help performance.
Okay, 60 to 80 grams in a liter. That's roughly a 6% to 8% solution, right?
Mhm.
Why is that concentration important?
It's precise for absorption. That 6–8% range is considered isotonic or close to it, meaning its concentration is similar to your body fluids. This helps it empty from your stomach quickly and get absorbed in the intestine efficiently. Too concentrated, like a thick sugary syrup, and it just sits in your stomach, potentially causing issues.
Got it. Efficient delivery. Okay, so we're fueled up before.
Yeah.
What about during long workouts, say over an hour?
Yeah. For those longer efforts, you need ongoing replacement. Glycogen stores start dwindling. The general advice is to aim for over 600 milliliters of fluid that contains about 60 grams of carbs per hour of exercise.
60 grams per hour.
Okay. And again, those isotonic drinks are really useful here. They deliver the carbs and help with hydration simultaneously, meaning you need slightly less total liquid than if you were just drinking water and trying to eat gels separately.
And a huge warning here for everyone listening. You absolutely have to test this stuff in training first.
Oh, definitely.
Do not try a new high-carb drink or gel strategy on race day. Figure out what your stomach can handle beforehand.
Non-negotiable. Trial and error is key. Okay, so that's during. Now, post-exercise fueling. The absolute priority is immediate recovery. Right after you finish, you want to kickstart glycogen replenishment and hopefully lessen that delayed onset muscle soreness.
Yeah.
DOMS.
That horrible pain a day or two later.
Yes, that's the one. A really good starting point, recommended in the sources, is 1 gram of carbohydrate per kilogram of your body weight.
Okay, practical. So if you weigh 70 kilos, that's 70 grams of carbs straight away.
Exactly. In that immediate recovery window, first 30 minutes or so, if possible, and you can boost that recovery significantly by adding about 30 grams of protein alongside those carbs. Protein helps kick off muscle repair.
Carbs for refuel, protein for rebuild. Makes sense.
And for people doing really high-volume training, like multiple sessions a day or very long weekend workouts, some sources even suggest repeating that 1 gram per kilo carb dose about 2 hours after the first one.
Assuming you're not training again right away.
Right, assuming that's your main recovery period.
Okay, we've thrown out some big numbers. 300 grams pre, 60 grams an hour during, 1 gram per kilo post. If you're hitting those targets around your training, you must be feeling pretty full. How do athletes manage to get enough protein and fat in and hit their total daily needs without just feeling constantly stuffed with carbs?
That really is the challenge of high-performance nutrition, isn't it? It requires very deliberate planning. You essentially have to structure your meals outside of that specific training window, your breakfast, lunch, dinner, snacks, to consciously hit your remaining protein and fat targets. The sheer volume of carbs needed around training forces that structure.
Okay, let's try and bring this all together there. Can we synthesize this into like a priority list for the listener, a start big, work small approach to managing carbs?
Yeah, I think we can. Priority number 1, the absolute foundation. Build your main meals around large servings of complex carbohydrates. And part of that foundation is hitting your fruit and vegetable target, the sources mention, aiming for 7 to 10 portions, which is roughly 80 grams each, daily.
Okay, foundation first.
Yeah.
Complex carbs, fruits, veg. What's priority 2?
Priority 2 is hitting your sufficient total daily carbohydrate intake relative to your body weight and your specific training demands. Look up the general guidelines for your sport and volume and make sure that overall daily number is adequate.
So meet the big daily target. And priority 3?
Priority 3 is using those simple sugars and isotonic drinks tactically. They are supplements, tools to be used specifically before, during, and immediately after exercise.
They're not the foundation.
Exactly. They support the main structure, they don't replace it.
That synthesis really helps. Knowing the difference between complex and simple the structure and nailing the timing pre, during, post, that seems to be the shortcut to smarter fueling.
It really is. And the best way to truly optimize it for yourself, experimentation.
Absolutely. If you're listening and you're training hard but constantly battling that chronic DOMS or feeling your performance is flat or just persistently tired midweek,
increasing your foundational complex carb intake is probably the simplest and most effective first thing to try.
So we've kind of established this tension, haven't we?
Yeah.
You need the steady foundation from complex carbs daily.
Mm-hmm. The logs for the fire.
But you also need those specific fast-acting sugars tactically to perform well and avoid crashing during intense periods. The kindling.
Yeah, it's a balancing act.
So, considering that balance, that tension between the slow foundation and the fast tactical fuel, here's something to think about. What systematic experiment could you start this week to dial in your perfect balance between foundational complex carb intake and your specific time-sensitive sugar supplementation needs.
That's the key question for optimizing performance.
Definitely something to chew on. Thank you for joining us for this deep dive.
See you next time.